All right, guys, are there any questions over the homework before we get started?
Questions over the homework.
What we're doing today is we're finishing up chapter 6.6. And the last piece of solving that we're going to be looking at is solving inequalities. Solving inequality expressions, these equations. Now, the way we solve inequality expression, these exponential inequalities, is almost the exact same way we would equations. We want one term, one base, so our 3 to the x, we want it by itself. It is indeed. We want the numbers on the other side. So realistically, this is already set up where we need it to be. 3 to the x is less than 20. Our next main step is to get the variable out of the exponent. And to do that, we're going to apply a log, its inverse operation, to both sides. Because we want to get that variable out of the exponent. What base do we want this logarithm to be put to? 6 would work, but there's a better number than 6. 3. We want base 3. Because for the most part, the base that we use really doesn't matter, but it helps out here for it to be 3. Because our power property says that exponent with 3 to the x, that whole exponent, we can move it to the front, telling us that we have x times log base 3 of 3 is less than log base 3 of 20. Now, what is log base 3 of 3? 1. Log base 3 of 3 is indeed, well, it helps if I don't put it to the 10. Log base 3 of 3 is 1. So I draw an arrow or a line through it, just signifying this simplifies to 1. So we have 1 times x, which is just x. So by using log base 3 on the left-hand side, we were able to simplify it to just the exponent, which was x. Log base 3 of 3 simplified to 1, giving us x times 1, or just x. Now we just need to solve for the variable. We need to get x by itself. It is by itself. So the solution for this here is that x is less than log base 3 of 20. And because we started out in exponential form, we started out with the variable being in an exponent, we do not have restrictions. Because we could put rational, irrational, positive, negative, we can put any number we want in an exponent and we're fine. So there are no restrictions, we're just saying that x has to be less than log base 3 of 20. And if we wanted to figure out what that is, log base 3 of 20 is 2.726833028. So any number less than 2.727 would be a solution. And again, I would take the log base form, just log base 3 of 20. We don't have to do the decimal approximation. We can leave it as x is less than log base 3 of 20. Questions on this here? We're ready for the next one. E to the x less than 2. We need one base, or the number or base by itself, nothing added to it, nothing subtracted from it, everything else on the other side. Well, we do have that, yes? Now we want to apply a log to both sides. That would make this base simplify nicely. And normally we would use LOG, but because the base is E, we use ln, we use this natural log of both sides, because the natural log of e is 1. And for this one here, we would move the variable or the exponent to the front, telling us that we have x times the natural log of e is less than the natural log of 2. Natural log of e is 1. If you're typing e into the calculator, it doesn't matter if the exponent's 1 or not, we have to put it. Calculator has to have a exponent for e. Has to have it. So that told us that this is 1. Again, I just draw that line through it with an arrow just signifying, showing that this reduced to 1. So 1 times x is x. And we're saying x is less than the natural log of 2. Because x started in an exponent, we have no restrictions. This is final answer. Questions on this here? Ten to the 2x minus 6 is greater than 3. Now at this point here, do I have one term on either side? Is there anything else with our base of 10? That's 10. We indeed do have the 2x minus 6. But luckily, since it's up in the exponent, we don't have to worry about it at this point. Because if we had 2 times 10, we'd have to divide both sides by 2. If we had plus 3 not in the exponent, we would have to subtract the 3. We have to get that base by itself, like we do in equations. But since we don't have it, we can move straight to applying a log to both sides. And since the base is not e, it is 10, we will use log. What base would we want for this here? Yeah, we'd want base 10 because the base of what we had is 10, yes? Do I need to write 10 into the base? No, because it is a common log. The base is understood to be 10. Power property says we can move that entire exponent to the front, saying that we have 2x minus 6 times log of 10 is greater than log of 3. And since it is common log, either calculator can tell me what log of 10 is. 1. That's why we chose log base 10, because that would indeed reduce to 1. 2x minus 6 times 1 is 2x minus 6. And we're saying that it is greater than log of 3. Is x by itself? Yes. All right, guys, focus up here. So at this point here, we do have to solve this for x. First thing we can do is add 6 to both sides. And if we do that, we get the 2x is greater than log of what? 3 plus 6. We cannot add the 3 and the 6 because the 3 is inside the log and the 6 is outside. So we just get log of 3 plus 6. Yes, x is indeed not by itself, so we have to divide both sides by 2, telling me x is greater than log of 3 plus 6 divided by 2. Questions on this here? Did the variable start out in an logarithm or in an exponent? Exponent. So there are no restrictions. That is the final answer, because we can have any number that we want in an exponent. Can't have whatever we want inside of a log. What's inside of a log has to be positive. We cannot have or take a logarithm of a negative number or the logarithm of 0. Neither one of those will work. Questions on this here? Are you ready for the next one? So the next one's asking us to find log of x is less than or equal to 2. Now, because we're talking about logarithms, we do have restrictions because the expression inside the logarithm cannot be 0 or negative. Now, for us here, the expression inside the logarithm is x. And what we're saying is that expression has to be greater than 0. Now, for this first one here just being x, it doesn't tell us a whole lot. We don't have to do a whole lot. We just are saying that x has to be greater than 0. Because if x is equal to 0 or less than it, we cannot take the log of that value. We will look at it later. Because we need that set up so we know what our restriction is, then we're going to compare it once we get our result. Log of x is less than or equal to 2. The log is by itself. All of our numbers are on the other side, so we can apply a base to both sides. And we want that base to be equal to the base of the log. In this case, the base of the log is what? 10. Whenever the base is not written, it's understood to be 10. And the 10 to the log base 10 of x. 10 and log base 10 will simplify out, leaving us with x. And it's telling us x is less than or equal to 10 squared. Well, I think we're good with that there. 10 squared is what? 100. And at this point here, we would want to get x by itself. Yes? It is by itself. Now, unfortunately, because x did not start out in an exponent, we have restrictions. Because it started out in a logarithm, we do have restrictions. And we said that for our restrictions, x has to be greater than or equal or greater than 0, yes? So 0 would be a restriction, yes? I'm going to plug it in for x in our solution statement. Because our solution statement was x is less than or equal to 100. So I want to see, is 0 less than or equal to 100? That is a true statement. And what that's telling us is that the values of x that are restrictions that we cannot have are included in the solution statement. Which means we're going to grab that statement and attach it to our solution statement. So 0 is less than x is less than or equal to 100. We have to remove 0 and all of our negative numbers from the solution set, telling us that the only values of x that work for this here are 0 is less than x is less than or equal to 100. Those are the only values of x that work for this here. Questions on this here? We good with this here? We ready for the next one? Log of x plus 9 is less than 45. Since we are starting off with logarithms, we will have restrictions. And the expression inside the logarithm has to be greater than 0, yes? What is our expression inside this log? It would indeed be x. There's no parentheses, and if there are no parentheses, the parentheses are understood to be just around the x, not the plus 9. If the plus 9 was included inside the log, they would have put parentheses around the x plus 9, signifying that everything is inside. I think that's very silly, but it is what it is. So really, again, the only restriction is that x has to be greater than 0. Questions on this so far? Now, because we have this plus 9 with our log, before we can apply a base to both sides, we've got to get the log by itself. So we have to do what? Minus 9 from both sides. Telling us that log of x is less than 36. What would we do next? Or, well, is the log by itself now? Everything's on the other side, so we need to put a base to both sides. And what are we going to put both sides to the base of? The same as the base of the log, which would be 10. Because our 10 to the log base 10 of x would simplify, leaving us with x is less than 10 to the 36. Is that a nice number? No, that's way too big. So we'll leave it as 10 to the 36 power. X is by itself at this point, so there's nothing else we have to do with that there. But we do need to check and see if our restrictions are included. And the way I do it, I just replace x with one of the restriction values, so 0. Is 0 less than 10 to the 36th? And it seems like I'm flipping it here. I'm taking this straight from x is less than 10 to the 36. 0 is indeed less than 10 to the 36 power. So that means I have to come over here and say that 0 is less than x is less than 10 to the 36th power. Because our 0 and negative were included in the solution set, we have to remove them from said set. Set numbers at work. Questions on this here? Be ready for the next one. For this one here, we have 2 times the natural log of x minus 1 is greater than 4. Let's go on and add parentheses around x minus 1, because it'd be nice to have one where the restriction isn't just x is greater than 0. Because what's inside the logarithm, in this case, x minus 1, has to be greater than 0. Whatever's inside the log has to be greater than 0. It cannot be 0 or negative. Now, since x is not by itself, we do have to solve it. We can add 1 to both sides, telling us that x has to be greater than 1. Because if x is 1, 1 minus 1 is 0, we'd be taking the natural log of 0. It doesn't work. If x is less than 1, we would have a negative number inside the log. It also doesn't work. Okay? So we mainly just did that to figure out what x cannot be. Now we just need to solve. Now we notice that there is a 2 in front of our natural log. First thing I would do is get rid of it. Telling us that we have the natural log of x minus 1 is greater than 2. Now the logarithm is d by itself. So now we need to put both sides to the base that matches the base of this log. And since it's ln, we know the base has to be e. So we're going to put both sides to the base of e. And our e and ln will cancel, leaving us with x minus 1 is greater than e squared. Questions on this so far? At this point here, we need to get x by itself. So the last thing we need to do is add 1, because our negative 1 plus 1 will cancel. Telling me x is greater than e to the second plus 1. Questions on this so far? Now we need to compare this to our restrictions. Our restriction said that x has to be greater than 1, yes? So if I plug this into our final statement, I need to see if 1 is indeed greater than e to the second plus 1. Luckily for us here, we can let the calculator tell me what e to the second plus 1 is. 8.389. Well, is 1 bigger than 8.389? That is not a true statement, so 1 is not bigger than this amount. So would any of our restrictions be included in this solution set? No. Since x greater than e squared plus 1 does not include any of our restrictions, we do not have to add the restrictions back in. There's nothing to remove. So it's just telling us that x is greater than e squared plus 1. That's it. Questions on any of this here? Questions on anything we've done so far? All right, I'm going to make y'all's life a little bit nicer with this problem here. I'm going to remove that square and that there. We're going to say 5e to the x plus 4. It will make things a little bit nicer. If you want to see what happens with that there, it is in the other videos from today. I'm just removing it. Actually, I'll leave it in there. We'll leave it in there. Because it's not going to make a huge difference in what we do or what happens. There is a twist at the end because of the x squared, but it's not a big deal. Now, because we have x in an exponent to start with, there are no restrictions. Because I can plug any number I want into an exponent. Even with it being squared, doesn't matter what it is. I can plug any number I want into an exponent. But before we do anything else, we need to get that base by itself. So what can we do first? Subtract 3. I always look for addition or subtraction movements first, adding or subtracting something to both sides. Because 3 minus 3 would be 0. Telling me I have 5e to the x squared plus 4 is less than 300. E is not by itself. There's nothing else to add or to subtract from both sides, so we're going to have to divide both sides by 5. Telling me e to the x squared plus 4 is less than 60. Is that base by itself now? Because we do have the x squared plus 4, but the e is by itself, yes? So we can apply a log to both sides. And what log would we apply to both sides? Our natural log, because the base is e. Now on the left-hand side, that natural log of e to the x squared plus 4 Power property says I can move the x squared plus 4 to the front. Telling me that I have x squared plus 4 times the natural log of e is less than the natural log of 60. Questions on this here? The natural log of e is what? It's still just 1. So x squared plus 4 times 1 is just x squared plus 4. Questions on how we got here? Now, the nice thing from this point on is we just need to get x by itself. We need to solve it. Now, there is no middle term, so we can just get x squared by itself. So we would subtract 4. Tell me x squared is less than the natural log of 60 minus 4. And for the most part, in your homework assignments, really, it's just going to go there. We're just going to add or subtract, multiply, divide, and be done. But before we move on to the next step, any questions on how we got x squared by itself? You won't see one where we're going to have to do this next step on the homework or on the test, but we're going to go on and look at it anyways. What would be our next step? We're going to have to square root both sides. Now, the square root of x squared is indeed x. And we would have the square root of the natural log of 60 minus 4. Less and. But when we take the square root of both sides, we have to add the what? Plus or minus. So, yes, x is indeed less than the natural log, or square root of the natural log of 60 minus 4. But that other side, that natural log of 60 minus 4, can also be negative, because when we square both sides, we have the plus or minus. Now, we would still have x. What would our inequality sign be? Would it be greater than or less than? It's going to be greater than, because we changed the sign of that right-hand side. We have to change the inequality sign. Again, one of these is not going to show up. But also, this is an and statement. Since we're talking about a less than, we started out with a less than inequality before we square rooted both sides. It's going to be and. If it had been great or than, before we square rooted, it would have been an or statement. So this is an and statement, really telling us that the solution set, we can actually write it as 1, that negative natural log of 60 minus 4 is less than x is less than the square root of the natural log of 60 minus 4. So our solution set is trapped between these two spots. And funny enough, those decimal approximations, it's not that far apart. Because our negative square root of the natural log of 60 minus 4 is negative 0.307. And the other side, our positive side, is 0.307. So it's between negative 0.307 and positive 0.307. For as big as the equation is, the solution range is quite narrow. Now, for the most part, what you're going to do, especially on the homework, you're not going to have to take the square root of both sides. You're not going to be dealing with those exponents. You're just going to be adding or subtracting and then dividing to get your answer. Questions on this here? And yes, there's more intricate stuff we can talk about that really is not going to show up too much here. That we can look at, especially looking at exponents like this power of 3. we could actually use the power rule or power property to move that 3 to the front, divide by 3 and solve. And everything's fine. Because 2x minus 3 to the third, if that value is positive, it's going to stay positive. Because we multiply a number by itself an odd number of times, sign stays the same. So if it was negative, it's going to stay negative. If it was positive, it's going to stay positive. The only place we have issues is when that exponent, like this one here, is even. Because an even, so a negative number to an even power is going to become positive. A positive number to an even power will still stay positive. So we have to be a little careful on those. But luckily, most of those don't show up.